Hello everyone. In the past video, we talked about fractals mostly with the 2x2 case and practice drawing some fractals. Now in this video, we're going to up the ante a little bit, and we're really going to look closely at this one particular fractal, and then we'll talk about the Sierpinski triangle. But first, this 1 out of 9 fractal, what's going on here? Well, you're going to take a square, and instead of dividing it into 4 sections, you're going to divide it into 9 sections, so a 3x3 grid. And you're going to color the square in the middle. And then just like with the previous activity, you're going to then take each of these blank squares that you've created, divide them into 9 pieces, and color the square in the middle, and rinse and repeat. So it's very, very similar to the previous activity, just now we're doing it with 3x3 instead of 2x2. And I won't show the drawing process because it's very similar to the previous fractals. But what's very different and interesting about this activity is that now we're looking at the area that we've colored. So we're really kind of like analyzing, okay, if we do this process over and over and over again, what happens to that area that's being colored? So this table's already started being filled out for you. And it's up to you and your students to try to see if you can figure out to fill out the rest of the table. So just looking at first, just going column by column. In the first figure here, we have 1 square colored. In the second figure, now we get 8 squares colored. And then in the third figure, they're saying that we get 64. Let's see, do we believe that? Well, in each of these small squares, we're coloring 1, 2, 3, 4, 5, 6, 7, 8. We're coloring 8 squares, and then there's 8 of these squares that we're doing that to yet again. So there should be 8 times 8 little red squares, and that is 64. And so it's going to be a challenge to sort of figure out how to explain this reasoning to students. So I really recommend practicing with your co-mentor how you plan on it, like explaining some of these counting arguments. All right, so for the next one, for 4 up, they say it should be 8 cubed. Well, I mean, do we believe that? Well, if we zoom in really closely and split these little white like white squares into 3x3 grid and color just the middle one, well, we're going to get 1 little colored dot for each of these. There's 8 of them, and then there's 8 in this group, and then there's 8 in this group, and so on and so forth. And so you can start counting sort of that way. And then for the area of each new square colored, we'll remind your students that the area of a square is the side length times the side length, right? And if you imagine that this is just 1, well, then this is 1/3, and this is 1/9, and so on and so forth. And so the area of, the first square is 1/9 because it's 1/3 times 1/3. And the area of each sort of dark teal square here is going to be 1/81th, and why? Because it's 1/9 times 1/9, and so on and so forth. The total area, this should be whatever this number is times this number, right? Because it's the number of squares that you've colored times the area of each square. So this one, 8 squares times 1/81th for each square gets you this amount of total area. And then this will be the sum. Or sorry, the total area remaining. I apologize. So it's going to be 1 minus whatever this box was. So this will be 1 minus 8/9 squared. Let me write that more permanently. And I recommend you simplify this as well. All right, so that's how you fill out the table. Again, I do recommend going over this, like how will you explain this beforehand. It will really help with the rollout of this particular activity. When you're done with this, there's a little more fun to be had with the Sierpinski triangle. So you're going to receive some triangular pieces, and you're going to be building the Sierpinski triangle with these pieces. So I really see kind of 2 ways that students will do this. One is the one that's suggested here on this activity sheet, which is put all your triangle pieces together. So you can imagine this big triangle is all the pieces have been pushed together in sort of like a tiling, sort of a grid, triangular grid. And then you're going to slowly remove pieces to make your fractal. So you can remove this middle piece, so take this out. And then once you've done that, okay, now you can remove these middle pieces And then you can do it again. You can remove these. And you can start to see that there is this fractals thing going on. And then you'll still have pieces, you know, all in here, and so on. So that's one way that you can build the Sierpinski triangle, is by slowly removing pieces from it. Another way to do it is to just sort of build it out. So you can start with like one small tile. Well, there's a triangle. And then to make the next piece, you get another triangle here, another triangle here. And then that shape, repeat it on each of the two bottom corners. So there's one, and there's another. Now this shape repeated on each of these two bottom corners here. So you get getting lost here. That's part of the fun. Oh, that's because I shouldn't put one there. There we go. So you have to make sure you follow your shapes. Otherwise, it doesn't quite work out. Anyway, I'm not drawing this perfectly because I'm not on a grid, but you can kind of see you're sort of building it out like this. You're repeating the pattern that you just completed at every bottom corner. And of course, there's other ways to build the Sierpinski triangle as well. But these are the two that I saw to be the most obvious. And play around with it. See if there are other algorithms and things that you can do to build up the Sierpinski triangle. That's a good activity.